Welcome to the Introduction to Immunology. I am really excited to teach this course. I know most of you have had Hematology 1 and Hematology 2, so we're going to take a lot of those cells and things that you've already learned about and start tying it into how the immune system works. We're going to look at how, not just how the cells work, but we're going to look at how antibodies are formed, what they do. We're going to look at different types of diseases that are involved with the immune system and some of the undesirable consequences of immunity and immunology as well. So let's go ahead and get started. First, we'll look at the history of immunology. Louis Pasteur is the father of immunology. He invented live attenuated chicken cholera, rabies, and anthrax vaccines. And when we go back and we think about the history and some of the things that they used to do, there's some things that come to my mind. For example, the first smallpox vaccines, what they would do is they would pick off the scabs of people that had smallpox. They would grind them up and have people actually snort them up their nose so they would become exposed to those antigens in the smallpox. And after their body was exposed to those, they would in turn make the antibodies or have the immune response that they were looking for. Obviously, we don't do things quite like that today, but there are some processes where they do take those actual organisms or the antigens of them, put them in a vaccine and inject them in you so your body does make antibodies to that disease. Now, if you did not have the vaccine, you'd never been exposed, that disease could be very life-threatening or detrimental to you. So by promoting that small immune response at the beginning, it's a lot safer. So we're going to dive into a lot of that as well. But we can thank people like Louis Pasteur for coming up with those vaccines rather than having to do things like, snort the scabs of people's smallpox, scabs and things. So what is immunology? Well, this is defined as the study of molecules, cells, organs, and systems responsible for the recognition and disposal of foreign non-self materials. So it's important to realize that it's the study of non-self materials and how we fight that off. It's how body components respond and interact. It's the desirable and undesirable consequences, which we'll get to in a little while, of those immune interactions. It's also the ways in which the immune system can be advantageously manipulated to protect against or treat diseases as well. Very fascinating. So there's different characteristics in the immune system that we must have. It has to be specific, okay? So you don't want to just fight off things that you shouldn't be. For example, you've got normal flora in your body, right? You don't want to fight that off. We need that to stay healthy. So it has to be specific or have specificity. It has to have memory. We all go and get those flu shots and we've all had our Tdaps and MMRs and things like that. That's so that it can create a memory. So once your body's exposed, it remembers. It remembers that you were exposed to it, so it's able to fight it off very quickly. It has to have mobility. It has to be able to move, okay? There's all different parts of the body that different diseases could enter. So we need to make sure it can get there and get there quick to help fight it off. It needs to have replicability. Can it replicate itself? You don't just need one antibody, you need many to fight these off. How does that happen? How does it replicate? You also have to have cooperation between different cells or cellular products. We're going to get into a pretty big discussion on T cells and how those work today. So the function of the immune system is to recognize self from non-self and to defend the body against non-self. You can see I have this here in all red. That's because it's very important to know. You need to recognize self from non-self and defend your body against it. The definition of immunity is the process of being protected from foreign antigens. And you may have heard of somebody being immunocompromised, right? This is someone who has a deficiency or damage to the immune system. Some examples of immunocompromised individuals would be the elderly, okay, a cancer patient who's undergoing chemotherapy and had a lot of their cells killed off. You may have heard of human immunodeficiency virus. Okay, that's because their body's T cells, T helper cells have been destroyed, so they are now immunocompromised. So we're going to go into great detail on some of those diseases and how those work and what happens to the immune system. So first we're going to start looking at some of the body's defenses. The very first line of defense that everybody has is unbroken skin and mucous membranes. We have membrane surfaces, we got secretions that will help fight things off. Those secretions have the physical ability to wash away potential pathogens, such as tears and saliva. In the tears and saliva, we also find something called lysozyme. Lysozyme attacks and destroys foreign organisms that are trying to enter the body. We also have antibodies that are found in our tears and saliva called IgA. IgA is also there to help defend against those foreign invaders. So that brings us to natural immunity. Obviously, unbroken skin, things like that are something that you're born with, right? So everybody's born with this natural ability to fight off infections. We call this natural immunity or innate immunity. You're going to hear innate quite a bit, so you're going to want to get used to that term. This is nonspecific. You're born with it. A baby is born with the ability to fight off certain things. They have what we call cellular and humoral defenses to fight those off. The cellular defenses are things like mast cells, neutrophils, and macrophages. And I don't know how much of that you've learned in hematology, but those have the ability to phagocytize, or they're called phagocytic cells. They act like, for lack of better terms, like a Pac-Man that goes around and eats certain bacteria or foreign material. So you have those when you're born, neutrophils, macrophages. Okay, they can do that. Then we have what's called humoral components. I think of more of these as they're anything but cells. Okay, so complement, the complement cascade, we're going to learn about that quite a bit, is found in acute inflammatory reactions. The lysozyme that I just mentioned, that's found in the tears and saliva. Okay, that is considered humoral. You're born with that. You're born with tears and saliva, right? Then interferon. Interferon is like a natural viral antibiotic. Okay, it fights off viruses. So you're born with those phagocytic cells, and you also have the humoral components of lysozyme and interferon when you're born. Some more specifics on this innate immune system. We talked about the granulocytes. We're referring to neutrophils, eosinophils, basophils, and monocytes. You do have some lymphocytes that do act when you're a baby, such as natural killer cells. But for the most part, your lymphocytes are going to be part of your adaptive immune system that we're going to get to in a minute. But we're still talking about the baby just being born. In the tissues, we have things called macrophages, mast cells, and dendritic cells. It's important to know what they're called in different tissues. Okay, so if you have a macrophage that's found in the blood, it's called a monocyte. If it's found in the tissue, it's called a macrophage. In the liver, it's called a Kupffer cells. I know we've mentioned that in chemistry before. The microglial cells are found in the neural tissue. Histiocytes are in the connective tissue. Osteoclasts in the bone. Mesenglial cells in the kidney, and alveolar macrophages or dust cells are found in the lungs. Be able to determine which ones come from where. Our immune system is fantastic. It's an ancient form of a host defense that appeared way before the adaptive immune system. And it focuses on something called PAMPs, which are pathogen-associated molecular patterns. If you look at this little bacterial molecule down in the bottom, you can see that it's got a certain pattern, and this is very cartoon and definitely not drawn to scale, but there's these pathogen-associated molecular patterns on the bacteria that your body is born being able to recognize. So for example, if a baby is born and all of a sudden great-grandma Ethel comes over and gives a big old smooch on the cheek, and grandma's got a big staph infection on the side of her cheek, the baby's immune system will have the ability to recognize those pathogen-associated molecular patterns on those staph bacteria and actually be able to fight it off, even though it has never seen it before. Okay? That's pretty neat. Sometimes they're called toll-like receptors as well. Okay, so after the baby's been born for a while, Aunt Ethel's been around for quite a while, and she keeps coming over to visit. The body's going to start to adapt to that. So the stuff that they're born with is still going to be in effect. We all still have it today. But now we're going to adapt and start creating that memory that I talked about. This is called the adaptive immunity, or also called acquired, because you adapt to it or you acquire it as you've been alive for a while. So the specific mechanism will selectively eliminate certain microorganisms, and it's activated when infection overcomes natural immunity. So we're going to create a memory to that, and these are the components that are going to be involved, and we're going to talk about these individually here in a little bit. The cellular components that are going to start to adapt include your lymphocytes and plasma cells. A plasma cell is essentially a grown-up B cell that secretes antibodies. We also have the humoral portion, which is considered antibodies and cytokines, and we'll talk about those in a little bit too. But just a reminder, lymphocytes are stored in secondary lymph nodes, such as lymph nodes, spleen, and tonsils. We have another slide on that as well. All right, so with these cell-mediated immunity, the B lymphocytes respond to a specific antigen. Plasma cells are B cells that secrete the antibodies. I just mentioned that. Then we get T lymphocytes. They don't directly recognize antigens of other living cells, but they act as something called antigen-presenting cells. These can be, macrophages, endothelial, glial, dendritic cells. We have three different types of T cells. Helper T cells, which are products are cytokines that can upregulate the immune response, so they help everybody out and say, hey, come on over here and help out. We have the T cytotoxic cells, which the product is direct cytotoxicity of cells. And then we got regulatory T cells that can downregulate the immune response. And we see a lot of things going on with this when somebody has HIV and converts to the AIDS virus. Patients that have, patients that don't have AIDS or HIV, okay, we have more helper T cells than suppressor or regulatory T cells. What happens when somebody gets HIV is the HIV starts to kill off those helper T cells to the point that the suppressor T cells or regulatory T cells start to increase. Pretty soon we've got more suppressor than we do helper, and the immune system becomes suppressed. Okay, so when we talk about going from HIV to AIDS, we're referring to these T cells and how they're being affected. So we have a whole chapter on that coming up later in the course. So it's also important to know where these T and B cells are stored. Okay, the primary lymphatic organs are the bone marrow, which is a major site of hematopoiesis after gestation, and the B cells and natural killer cells are actually produced there. The thymus is where T cells are produced and mature. Okay, make sure you know that those are primary lymphatic organs and what they do. Secondary lymphoid organs are when lymphocytes meet their antigens. These are lymph nodes, spleen, tonsils. We've got malt and galt, and also salt. I've seen galt, gut-associated. There's mucus-associated, skin-associated, lymphoid tissues. Here's our cytokines. It's important to know the definitions of these as well. These are produced by T lymphocytes, and they act on various elements of the immune system. I call it like a chemical mediator that causes things to talk to each other. We also have interleukins, which are soluble mediators that act between leukocytes as well. Interleukins, leukocytes, talking between each other. It's kind of I like it when terms sound like what they do. So here are the different types of acquired immunity that you have to be responsible for. You have to know the difference. There's a lot of quiz and test questions right here, guys. So we have active and passive, natural and artificial. So let me explain, because if you think about it, it's going to make a lot more sense. So let's start with active natural. So in order to create an immunity after you've been around for a while as a baby, and you've got something active to acquire, for example, getting an infection. Let's talk about measles. If you actively get the measles, okay, that's natural. You're naturally getting the measles and creating an acquired immunity. Active natural. Active artificial is still going to create that immunity, but it's getting a vaccination. So I think of actively artificially stabbing someone with a needle. So it's active because you're actively giving someone a vaccine, and it's artificial because it's in a vaccine. Natural is the same thing, but it's an infection. Okay, you're naturally getting it from Aunt Ethel, who kissed you, happened to have measles this time. Passive is something that just happens naturally through the body, okay? Or it's actually giving someone the antibody itself. So passive, natural, would be breastfeeding, okay, breastfeeding mother, or in vivo, okay? The artificial passive is the infusion of serum or plasma. Here's an example, and people usually struggle with this one. Most of you have had the hepatitis B vaccine, which is an active artificial vaccination. Okay, they're actually giving you some hepatitis B antigen to help you create a long-term response. Let's say you've been exposed. Okay, you get a dirty needle stick and you don't want to get hepatitis B, right? Because we don't. They might give you hepatitis B immunoglobulin, which is the actual antibodies in some serum, and inject them into you. Getting those actual antibodies is considered passive artificial, okay? Make sure that you know the difference between each of the four of those. Another type of immune response that we see and you hear about quite a bit is hypersensitivity. Do you know anybody that's allergic to bees or allergic to, I don't know, gluten? Okay? There's all different types of hypersensitivity things that we see. And this is the antibody IgG is the most commonly associated antibody with anaphylactic reactions. So when we have exposure to antigens or allergens, okay, we have the development of an IgE antibody. This IgE binds to our mast cells, okay, and they can release histamine and heparin from cells like basophils, and they make you itchy and sneezy, okay. We have an antigen interaction with the antigen-specific IgE bound to the surface of those mast cells, and it releases chemical mediators from them. The action of these chemical mediators can have effects on organs. So it can be quite detrimental to the person if they're severely allergic. Okay, because it can range from anything from getting a rash up to having a severe anaphylactic shock. One of the last things that I want to mention is a major histocompatibility complex. Our body has the ability to recognize itself. We all have a tissue major histocompatibility complex going on. So for example, if I need a kidney, okay, and I get Lori's kidney, my body is going to fight off Lori's kidney like crazy because it's going to recognize that's not my major histocompatibility complex, okay? If I were to receive a kidney of an identical twin, my body wouldn't have any issues at all because it would recognize itself as self. So when we talk about some of the tissue transplantation and things like that we're going to get to at the end of the quarter as well, it becomes a very messy thing to try and give somebody else's organ when that body doesn't recognize that major histocompatibility complex. We recognize our own, we don't fight off our own body, okay, unless we have some other issues that we'll talk about later as well. On this slide I have a nice little review of the different components of the immune system. I recommend making note cards not just on the other things that I talked about, but each of these different components. You do need to know the difference between them and a little bit about what they do. This concludes our PowerPoint for the first part of Module 1, and I look forward to working with you guys in Module 2. Have a great day.